All right, let's go ahead and get started. So I assume you all can hear me. So we'll go ahead and get started real quick. Where are the recordings being put? Um, yeah, I'll answer a few questions before we actually get started. So let me go ahead and link you guys the recording sheet real quick. Give me 1 second for that. So today's agenda, basically, we're gonna finish up Fall 19. So we didn't finish question 1.2, which is this input file question, and we're also gonna finish on the multiple choice questions. After that, it should be like 6:45 or 7, so we have like an hour and 50 minutes to basically answer, any of the miscellaneous questions and stuff, talk about the exam structure and stuff. So from last time, some people emailed me and they wanted to cover more stuff with pointers, so I'll start off with that, just go through some examples of that, some like clarification questions on that. Then after that, we can go through anything you guys want. So I'll launch a poll at like 7-ish and I'll answer any questions you guys do have. Let me go ahead though and link you the sheet where all the recordings are posted again. And here we go. Right there. We also link the drive for you guys so you can review all the content you guys need before the exam. So 1 second on that. All right. And this is the link to the drive. So this is where all of our review documents are and stuff, all the other recordings, all that fun stuff. So see if you have some questions in the chat. So do people suggest using an IDE or something like that? Yeah. So last time I talked about using Visual or Xcode or whatever you want to use. I think it's helpful because it helps you format your code. And I think last time we actually had a pretty good case of this where I was writing code and I got like a type mismatch. So it's definitely good to do that because you'll see like, oh, I'm trying to compare a int to a pointer. I can't do that. So it's really good for checking to make sure that your code will like compile. But again, your points are determined based on like what you write for the code. In the end, it doesn't matter that much if your code compiles or not. What matters though is that like you have the right process. So a good example would be, oh, if you're doing like a question, you have like the while loop implemented properly, you're doing the right checks, but maybe you just forgot to put in like a semicolon. They won't dock you off points for that, right? If your code like looks solid and you have like the right thought structure, you're chilling in the end. It doesn't. The emphasis should really be placed on like, does your code make sense? Like if someone were to read this and say, yeah, that makes sense. That's the main point of like writing the free response questions. So definitely an IDE helps with that. I missed the cheat sheets from the last video. We didn't actually have any cheat sheets from the last video, so you didn't miss out on anything for that. Definitely go through and watch the recordings for last time if you guys haven't. We went through questions 2, 3, and 4 in depth. Peter explained polymorphism and class structures. I went over the strings and array portion, and we also went over the first question for question 1. So we're going to pick it back off right now and go over the file question and then do some multiple choice. After that, we'll just go over whatever you guys want to go over. So that's going to be that. Any questions before we get started on the logistics and stuff? All right, I'll assume not, so I can get out of this. Let me go ahead and pull up the exam. Perfect. All right, so last time we did question 1 right here, so if you guys miss out on that, watch the recording from yesterday. So this is the last free response question we'll cover today. This is question 1.2. You mentioned late in lecture yesterday there was a cheat sheet. There wasn't. You want one? I made one. Okay. Yeah, sorry about that. I must have miscommunicated. We didn't have a cheat sheet for yesterday. So, and I don't have one for today, but what I do have though is just like myself. So if you have any questions about the content of the exam, happy to answer that. We also do have some like worksheets from previous exams that Peter made. Those are located in the drive under their respective folders. So if you want to like learn more about pointers, let's say, I know Peter made some resources for that, and those are available in the drive under their respective links. All right. So today's question we're going over is the input question. So input streams are, I wouldn't say that common. They're probably only one question in the exam, but they're pretty easy to get wrong because there's a lot of semantics that are involved here. So basically this question is asking us to, for a given number n, we want to output the nth word on each line. So basically we're going to use argc and argv here. So this is pretty similar to project 2 and 3. So right here we can see that the user is calling the program .main with to and from input text. This also says if no input text is specified, then we should just read in from cin. So does the question make sense, everyone? So we see right here that we're given these 5 words. We're reading every second word. So we read the first word, she, skip this word, then to, skip the word, store. And we should always put a comma here. So the big thing for this question, though, is error checking. So we have to make sure that there are enough arguments. If there are not enough arguments, return 1 from main. And that says you don't have to check for other errors. So if you see this and it only says check for this one error, There obviously could be more errors, like what if our input file doesn't open? We're not responsible for that, so that's good. So are there any questions about like how this question's worded or like what's expected of us? All right, good stuff. Let me go ahead and just find the function header for this. They don't give us one, so we have to make it ourselves, which is fine. So let's go ahead and do that. Let me go into Visual Studios real quick. Okay, perfect. So we have the solution from last time. Let's go ahead and get started. Okay, so we have int main, and the important thing to realize here in writing this is that main's going to have the arguments argc and then char pointer argv. One thing to note here is that if you write char pointer argv like this is equivalent to saying char pointer argv. The reason being is that remember that argv like this is an array, and arrays just decay to pointers. So these two are equivalent for that reason. So you can write either of these in your exam, you'll be fine. I think understanding why they're equivalent is pretty important too. Again, it's just because arrays decay to pointers, so these two mean the exact same thing. So what we're gonna do here is we first need to read in argv, and I think handling the errors first is important. So we can see, let me get my pen out real quick. We can see right here that we have to check for errors, and the only error we're responsible for checking is that argv is there enough arguments. So we know that from the spec right here, we're either entering an input file or nothing. If nothing's specified, that means we do cin. So we basically just want to make sure that argc is 2 or 3, because we always have to enter this and we always have to enter this. This last argument's gonna be optional. So this is pretty similar to what we did on project 2, where it's like, oh, you can enter in your new width if you want to, but it's not required. So we check for that. So you have a question in the chat. How much time would you say we should spend on that problem? On this problem, if you're comfortable with strings, I'd say like 7 or 8 minutes. But again, I recommend facing the problems you're most comfortable with first. So if you feel comfortable with like pointers and stuff, definitely go to that section of the exam first. It's really good to go ahead and do the questions you can do easily first. That way you can guarantee the most points on those and then work on the trickier questions later. So again, I'll probably take about 20 minutes this question just so I can explain the thought process. So if you are confused on it, that's why I'm spending more time on it. But typically you should expect to spend like half the time I'm spending on this question, just because I'm going to go more in depth into it to make sure you guys understand the concepts and all that stuff. So again, we want to error check first. So to error check, we just want to make sure argc is 2 or 3. So to do that, all we have to do is just go ahead and enter in our if statement and check argc, is it 2 or is it 3? So what's happening here is, this is their example. I don't think it's that intuitive the way they wrote it, so I'm gonna go ahead and change it to this. If argc is 2 or if argc is 3, that's valid, right? But we want to see if it's invalid. So we're just going to add negation here. And what this is doing is just making sure that argc is 2 or 3. And if that isn't true, we're going to return 1. Because the spec says right here, if it's not true, return 1 from main. So even if you just have this, that's like a good chunk of points. So we're pretty good there. The next thing we have to do is we actually have to get the number of words. Like the n argument, right? We have to get this n right here. Remember that we're reading it in as a char pointer. So we have to convert that over to an int. So I'll say int n. We have to use the a to I function. This just converts the argv stuff into an integer so we can work with it. Again, it's way similar to project 2. And we know that argv1 is going to be n because this is the second argument. So we go ahead and put that in. So this sets n, and now we're good. The next thing we want to do is there's 2 options. We can either read in from our input text or we can read in from cin. So we know that if we're going to read in from cin, that means that we only have 2 arguments. So we've already passed this. This basically tells us we have 2 or 3 arguments. So if we have 2 arguments, so if argc is 2, this tells us we're reading from cin. Otherwise, we read in from the file. All right, awesome. So what we're going to do is we're going to go ahead and create another function that's going to handle us reading in the input. So let's go ahead and call this read. And this is one thing that's pretty confusing, so I'll go more in depth in this. But it's basically, what is iStream? So we pass this thing called iStream. We'll call it is. And we also want to pass in our int n. So what does iStream mean? iStream is basically just an input stream. You can think of this as cin, but you can change where you're reading it from. So in totality, this basically, you can replace it with cin. So is is basically just saying, am I reading in from cin? Am I reading in from a file? Am I reading in from an image format? So remember back from project 2, we had to use like iStream for an image. It's basically the exact same thing, except we can substitute iStream for just being cin. So we can use the exact same operators like this for cin. Instead, we're just going to specify what we're going to read in from. So that's pretty nice. So let's go ahead and make a temporary string we can read in from. We'll call it string, because we can do that. And I'll have this condition, while is string. What this is saying is basically, while we're inputting a word, go ahead and do everything inside of here. Realistically, you should have like a stopping word here. This question doesn't specify it, but like, let's say, for example, you wanted to read until the word stop. You could just include this. It's not part of the question, it's just an example. I could do like, and string does not equal like stop or something. Again, we don't have to do that because the question didn't specify it, but this is a good way to like stop reading in. So now we're going to go ahead and we're just going to output our string with a comma. Like this, so string, and we're going to output a comma. Like this. So it's all in one line. And now what we're going to do to actually output the string is we're going to implement a for loop in here. Inside this for loop, we're just going to go ahead and take in the string like this. Should be lowercase n, sorry about that. It should be a string. So what's happening here is we're basically taking in this string and we're going to output it, and then we're going to input our string into the input string for the values of n we specified. An easier solution to this that I think is a lot more intuitive, so I'll put this right here. We're only going to output if n is a multiple of that number. So we're going to have mod in here. So we're going to say if n mod 2, or sorry, if we'll have a counter up here. So like int counter equals 0. And this basically denotes like what word we're reading in. So like she would be 0. And so we're going to go ahead and say if counter mod n. So that's basically saying, is this divisible by 2? Is it an even divisible by 2? So that makes sense, right? Because we want to print out she, 2, and store. So she is 0. 0 mod 2 is 0, so we want to print it out. Went is 1. 1 mod 2 is going to be 1. And since it's not 0, we want to go ahead and not print it out. So if this equals 0, we want to go ahead and output. So we go ahead and we cout string. And then we always want to update our counter. So does that logic make sense to you guys? We're basically reading in the string one by one. And in here, we're just seeing if that string, the number we put in, is a multiple of the number in the argument. So we're just saying, is this string like a 2, right? Our argument's 2 here. So it's 0, 1, don't output, 2 output, 3 mod 2 is going to be 1, don't output, 4 mod 2 is going to be 0, output it. And then we have this in the end. We also need to have that.
I kind of have a question about postfix.
Yeah, sure.
Yeah, so in the if like condition, could you? I'm kind of curious how far
if you do
can
this
postfix. Yeah.
Yeah, that's completely fine. Yeah, you can easily do that. So what happened? That's a great question. So I can go ahead and get rid of this and just do this for simplicity. What's happening here is we're going to evaluate counter at its current value, mod it with n, and get 0 or some value, right? After we do that entire operation, then counter will be updated. So let's say, for example, counter is 7. What's going to happen is it'll say, is 7 mod n equal to 0? After that, it'll change counter to 8. So yeah, absolutely, you can do that. And then we don't, and then we don't need an else statement here just because, yeah, we don't need an else statement because we only want to execute this code. There's no else statement involved here. I think the lecture notes say something about not using post pre-increment in larger expressions. So again, like it does make it more confusing, but it's not like bad technically. This will still work. I think just like for clarity's sake, it is always good to do this because it's apparent what you're trying to do here. But again, like what he mentioned will obviously work. So you can do either way, whatever makes more sense to you. But yeah, you can do post increment there. All right. And then in here, if argc is 2, we just want to go ahead and specify our input stream to be cin, like this. And then we'll just put our n in, like that. Otherwise, we want to work with our file. We know that our file is going to be argv of 2. So let's go ahead and create an if stream object. That's basically a file object. And then if we do is, we'll call is in this case. We're going to go ahead and specify the file name is going to be argv2. So this is the exact same as saying, what am I missing here? Why is it not like that? Incomplete type not allowed. Oh, I didn't include if stream. Okay. Okay. Did I spell it wrong? I think it's just iStream. All right, whatever the library is called for files, you can include that.
fstream.
It's fstream. Thank you. Thank you. Okay, that should fix it. Yep, there you go. So yeah, include fstream, and then there's ostream for output. So if you guys did have to output to a different stream, you'd use ostream, and that allows us to use os like ostream. All right, I think it's os stream. Ostream. Yeah, there you go. If you had to do output, you would use ostream like that. But we're only using input because we're reading it from a file, so we'd use if stream. So this is equivalent to us saying if stream is, we'll call it ISS, and then we'll do like is.open. These two are the exact same thing. This right here is just a constructor, so you can do it all in one line. So if you see either of these, they mean the exact same thing. But all we're doing here is we're basically just creating an if stream object called is, and we're saying it's going to be some name named argv2, and that'll open it for us. And then since we have this object created, we know we're taking an if stream, an iStream argument, which could be any stream. So it could be cin, it could be a file, could be anything we want. We'll just go ahead and put this in here as read. Oops. We'll put is in here, and then we'll pass in n. Is this question similar to the same difficulty of a question like this in the exam? So I know they made the exams a little bit easier due to the online format and the minimum competency rule, which basically just means you have to get a certain score in the exam to pass the class. So this question was definitely tricky. This was my year. So it was definitely a hard question, just understanding how to navigate these if stream objects and stuff. But yeah, I'd say this is pretty representative of a question difficulty in the exam. Are there any questions about like how you'd solve it? Yeah, go ahead and you can talk. If you raise your hand, you can type in chat or talk. How much time would you say we should spend on that problem? If the exam's 2 hours, there's probably like 5 or 6 questions that are like this in terms of length. So I'd say like 10-ish, 10, 15 minutes. Again, it depends person on person. Some people can solve these problems a lot faster than others. If like iStreams and file streams are your strong suit, then definitely try to do it first. It'll take about 8 minutes or so. Again, it depends on like how good you are at this kind. I know it's like a very like loaded question because like, oh, it depends person to person. But I think the target strategy should be start with the exam questions that you know you can solve easily. So if you know you're good at polymorphism, go ahead and solve those first. If you know that like file streams are your weak suit, I'd recommend just solving this one last and let the cards fall where they may. But obviously, like try your best at all the questions. But I don't think it's like the best strategy to get yourself bent out of shape over a question you can't solve. if you get to a question, you're like, I have no idea how to do this, just skip it. Go to it later. There's no point in wasting time in a question that you don't think you can solve. And if there could be a 5 to 6 problems like this, what would we see otherwise since no MC? They'd have conceptual questions where it asks you a question like, if I went ahead and we made it so like you'd output to different stream, how would you like resolve that? And you type in a box and say, oh, you would basically just say you'd pass in a O stream object to this, and instead of C outing, you'd OS it. That could be an example of like a follow-up question they could ask you. They might ask like 1 or 2 more questions regarding like file streams that could be like, check all that apply. There's no like multiple choice section, but there's still multiple choice questions on the exam. So there's that. But yeah, any questions I can answer about this? I know file streams are pretty complicated stuff, so I'm happy to walk through it again if you guys want.
I had a quick question.
Mhm.
It's a kind of a hypothetical question, but basically, if you had to like, if given a file in the arguments,
Mhm.
so like, basically, if you're not given it, then you have to do cin. But say
Mhm.
you were given one, and you were also required, if given a file, to like write to the file, then in the read function, would we pass in like an OS stream object?
Yeah, exactly. So let's say we alter this question and said we are also given as arg3, or how about this? If you're given an argument for the file, you also have to write to that file. It sounds kind of scuffed though, because we have to overwrite the file, but let's play with it, right? So let's see if we're on the same page here. Basically, the question's modified to where it's like, okay, if you're given an arg2, if you're given a file name, you have to write instead of saying cout. So let's go ahead and try that out. What we could do here is just say ostream os. And this is basically it. You can treat it the exact same as like cout, right? This is like cout, but we can specify. So what we do here is we replace this with os, and then in here we would just put cout for the cout statement, right? And then if we want to specify a file in here, we can go ahead and say ostream os. In this case, it's the exact same file, so we'd say argv2, and then we'd pass in os. But I don't think it will like that because we're already using that file. So let's go ahead and just make it argv3. Why is it mad? But yeah, that's a general idea, though. Does that make sense?
Yeah, totally.
All right,
Thanks.
awesome. Yeah, of course. Any other questions about this stuff? Oh. And again, guys, we have like 2 hours, so no questions bad. I just want to help you guys out however I can. So if anything's confusing here, like unmute, I'm happy to help it out. What's the difference between stream and iString stream? So yeah, that won't appear on the exam. It's a pretty niche topic, but it did appear in project 2. So basically an iString stream, it will convert, it's weird, it will like convert the output of a file stream to a string object. So let's say, for example, you are outputting to a file. You can also convert that into a string so you can compare it. It's mostly used for debugging purposes. Like in project 2, you would have to use iString strings to like figure out if you're outputting it properly. It's the exact same thing, but I wouldn't worry about it. It won't be on the exam. Like if it is, then that's crazy. No one will get the question right, but it most likely won't be on the exam. So I wouldn't worry about it too much. It's just something to use in project 2 for debugging purposes.
How did you know that you needed to do the void like read function?
So you don't have to do this. I could easily have just implemented it into my if and else statements right here. I just did it because it makes the coding a lot easier, because when I saw this question, the process is the exact same depending on if you're doing cin versus the input file. The only difference is where you read in from. So I just thought, okay, maybe it'd be easier if I just had this code right here. And instead of like replicating it over this, I just recognize the only thing I have to change is is. That's the only line. So if I were to go ahead and let's say not have this function, I'd go into here and I would just replace this with cin. And I replace this with n. And then for this, I would do the exact same thing. So you can do this without the helper function, But my point here is like
Okay.
it's really helpful because all we're doing is changing this one line of code. So sometimes I think on this exam they don't do it, but if you take 281, they'll say in certain free response questions, oh, you're capped on like 19 lines. So it's a good coding practice. It's not necessary. You'll still get full points. I just thought it'd be easier to explain like, oh, like look at this, guys. Like IS like is literally the exact same as CN. It just depends like what you input. So it was more for like a learning purpose, and also it's like good coding practice. But you could easily solve this problem like this. It doesn't really matter if you have the function or not.
Okay. Is this the same level of difficulty that like we should expect on the exam?
It's a hard question because they changed the exam by year. I think the exam's a bit easier because it is online, and also the fact that like they did make it so that you have to get a certain score on the exam to pass the class. So I think this question would be a bit more difficult, but I think it's still a good question to study because it was on an exam from 2 years ago. So you could expect to see something this difficult on an
The
exam.
exam.
Yeah.
Okay.
Will be graded on efficiency, readability of the code. You will be graded on like if they can read your code or not. Like if your code doesn't compile and it makes no sense, then they might not grade it properly because your code's complicated. But like I don't know, if my code's like really like inefficient, they won't care. This class isn't graded on inefficiency. It's graded on like, do you solve the problem? So you can write your code inefficiently, that's fine. As long as it makes sense to a grader, you're fine. Can you take argc and argv as a parameter to function other than int main? I believe you can actually, but what you can do also is just like right here, I converted n using a to I. It's a lot more efficient and like readable because right here I'm basically just saying n's gonna be the n's gonna be the second argument, which is this right here. So it's a lot more apparent to a grader like what I'm trying to solve here. Yeah, if your code feels like a bit like cumbersome, just look at their like, okay, their solutions. Like I'll pull it up real quick, like what they wrote. I think that their solutions like very unreadable, especially for 280 level. Like okay, here it is right here. This is their solution. And it looks pretty similar to ours, but the one thing I want to point out is this. Like this is very unreadable, especially for like a 280 perspective, because a lot of you guys, this is your first coding class, and you're like, yo, how are you doing a for loop in one line? Like you can do that, but it's a very niche thing that most people don't know about. So their solutions, they write them like really cumbersome. So you can write code mostly however you want. If it makes like some sense, I think you're fine. But like, just make sure your code's like somewhat readable. Can you also explain why the comment in the line 21 of the code is true? Yeah, sure. 21. Yeah, sure. So basically what's happening here is that we can think about argv, that's a pointer, right? An array in and of itself is just a pointer. Argv points to the first argument, or I guess the 0th argument in our list of arguments. So we say argv. This points to main.exe, a string of that. So if I were to go ahead and like, if I were to run this, like cout like dereference argv, that would output main.exe. So what's happening here is that since this is a pointer, this is an array, this decays into a pointer. So these two are equivalent because this is an array, and all arrays do, or they're just pointers under the hood. So that's why that works. Can you just declare an iStream variable and assign it to CN SStream object, depending on which case it is? Yeah, you can do that as well. All right. Any other like clarifying questions I can answer on this? Again, this is a pretty hard question, so if you didn't get it, don't feel bad about it. It's a pretty hard question. All right, we can move on then. So I know that multiple choice isn't covered explicitly on this exam, but I think these questions should help clarify any concepts because multiple choice is the best way to like understand the concepts behind it. So even though there's not going to be a direct multiple choice section, I think it's still really, really important to go over it because these questions will also appear in your exam. And also if you are coding up a solution, it's important to understand like, oh, can I do this? Or what does this represent? Because a lot of questions will rely on that. So we'll go ahead and we're working backwards just so we did it backwards last time. So I'll just continue working backwards. We're going to start with this question right here. This is revolving around like outputting like strings and C-style strings. So this question is pretty important. I'd say it relates a lot to section 1 of the exam, which covers strings, pointers, and C-style strings. So we can get started on this. I'll have you guys like think about the solution on your own for a couple of seconds, and then we'll talk about it as a group. So let's get started. So first question, we're calling world of X, Y, and Z. We see that right here, this is hello, and Y is also hello. And what it's asking us to do is we're going to input two strings, or two char arrays, and we're going to compare them. If they're the same, we're going to output whatever this is. So for this question right here, we're basically asking if X and Y are the same string, we're going to output hello. But it's asking us, like, what's the actual output going to be? So does anyone think they have an idea? And I'll give you guys like 30 seconds in this one.
I thought we could just say it.
Oh yeah, go ahead and talk.
Oh, I thought it would be D.
Yep, exactly. Why do you think it's D?
Well, considering that the char Y
Mhm.
is a C, if I'm not mistaken, a C style string, and then the char X isn't, and it's forgetting the null terminator basically in Y, if I'm not mistaken.
Yep, no, 100% correct. That's great reasoning. So yeah, this right here is missing the sentinel value. So whenever they compare these strings, it's going to compare H to H, E to E, L to L, L to L, and O to O. But the issue is we're missing the sentinel value, so that it's going to keep on reading that string. And that will cause it to say, oh, the sentinel value is not equal to whatever's here. And that will cause an issue. Whenever you declare a C-style string, you have to be sure that you are including the sentinel value right here. So in the previous, I think in one of the questions right here, you guys were here yesterday, we had to actually manually add. Actually, let me go ahead and see if I can pull it up in my IDE. It'll take too long, maybe. I can get the solution back. Okay, we can't get it up. Anyway, at the very end of this question, we basically had to insert this into the end of our string. That's because every single C-style string has to incorporate this value right here. Because whenever we're reading a C-style string, we read it character by character. So we go H, E, L, L, O, and we know we're done with the string once we find this value. A couple of facts about that you have to know for the exam is that this sentinel value is the equivalent of false, which is also the equivalent of the null pointer. Right? So if you ever see code like while, and it's a pointer, have you guys seen this before, where it's like while PTR, go ahead and do all this work right here? You guys have probably seen this before in some of their code. What's happening here is that we're just checking, is this pointer pointing to valid memory? If it's pointing to the null pointer or it's pointing to the sentinel value, that will evaluate to false, and while false means stop this loop entirely. So whenever we see the sentinel value, we instantly think, okay, we're done reading the string. Let's go ahead and go to the next string, or let's stop reading it. If we're missing this, we'll continue reading the string, and we're not really sure what the behavior is going to be. So that's why when we compare the two strings up here, they're not the same because this is missing the sentinel value at the end. As he said, this is a C-style string, and we're not incorporating the sentinel value at the end. So that's what's going to happen there. Any questions about that?
Yeah, actually for question 5, it was me and a couple other people in the chat were a bit confused about this. So the equal operator for C strings, doesn't that compare if their addresses are equal?
Yeah, it does.
Okay. So like that would be the reason this prints nothing, right? Not because
Yeah. Oh, yeah. My apologies. I was referring to something else. I didn't make that clear. My apologies. Yeah. So basically, this compares the addresses, and since they live at different addresses in memory, like this char X and char Y are like living in different places in memory, then the addresses won't be the exact same. If you're comparing it character by character, then yeah, that would be the case. Yeah, it compares the address of the first element. Yeah. Should be a bit more clear. My apologies.
And is the address of the first element the same as like the address of the array?
So this right here, this refers to the address of the H. And then if you were to compare this, we compare the address of that H. And since these H's live in different places in memory, then what's going to happen is that it'll just compare the addresses of this H and that H, or this hello, and it'll result in, what is it? It won't print this out because they're obviously different addresses. So then question 6 should be pretty easy then, because we're comparing y and y, but there is one small caveat here. Since we're comparing this right here, it's going to be for 6. Actually, what do you guys think it's going to be for 6?
Wouldn't it print hello because they live
Yep.
at the same address?
Yeah, exactly, because they're the same address in memory. Absolutely. All right, 7, this one should hopefully be pretty easy. Recall what the null pointer does and what its address is in memory, if it even has an address. Yeah, whenever you declare a C-style string, you don't have to necessarily declare its size, because if you just declare it, like if I say like char, like const char pointer equals hello, like that, then we don't necessarily have to declare a size, because the compiler will go ahead and like compute the size since it is declared at runtime. Arrays, you have to declare like the size at runtime. I couldn't just do like const char pointer like array. I'd have to either specify a size or a value at runtime. If you don't, then you'll get undefined behavior, so that's not good. But yeah, for 7 right here, the null pointer, again, its address is 0. Like, it's a null pointer, so it doesn't really have an address. And we're comparing it against x, which obviously has some address in memory for that. So when we compare the two, it's going to be nothing.
Wait, quick question.
Yeah, sure.
If you were to dereference a null pointer, wouldn't that be a runtime error or a compile error?
Compile error. So if I go, I can show you real quick, actually. It's a great question. So yeah, never do this because it'll always break. If I have like int pointer x equals null pointer. This is valid because I'm just saying that like I'm going to declare x, but it points to nothing. And if I see out x like this is outputting the address. So you get to see what happens here. Let me run this. So you see how it's like all zeros? The null pointer is always going to be 0, like that. If I do this, it won't work. It'll be a runtime error. Because yeah, x was null pointer. So it will be a runtime error.
Thank you.
Yep, of course. And by the way, if they ever ask you questions like this, always feel free to open up your IDE and just test it out yourself. But yeah, some great intuition there. All right, similar question. If we output y, we mentioned before that y has some issues. Most importantly, there is no sentinel value here. So as I mentioned before, whenever we output this string, we're going to output character by character, and we'll keep outputting until we find this value. But since this value is not here, we don't know when we're going to stop outputting. So it could be like hello, and then like maybe it ends, but we actually don't know. So it's going to be undefined for 8. So I'll show you guys in my IDE what will happen. So if I go ahead and I just create char, let's copy exactly what they did. Char y equals h e l l oh, like this, and I see out y, you get some really weird behavior. So you see like right here, it's pretty messed up. That's because it outputs the first 5 characters, but after that, it's searching for some null value. And again, we don't know what the null value is, so we're gonna keep out outputting stuff. And probably what happened here is that like it's trying to output these weird characters that my compiler doesn't know how to handle it. Because like, you know how computers output stuff. It basically like will reference what the character is in ASCII, which is basically like, oh, A is equal to this number in memory, right? Like A is represented by like 140, I think. And we're outputting like random memory, so our compiler doesn't know like how to handle those numbers. So it's gonna output like these crazy characters and stuff. So that's what happens when we don't add the null character like that. So if we output dereference y, what do you guys think is going to happen? Think about how C strings differ from traditional strings. or traditional pointer, sorry. What do you guys think is going to happen here?
Would it not just be H?
Absolutely, yeah. That's because whenever you do this, it's going to output the first thing in the string, which would be H. So yeah, great reasoning there. And then for 10, we're outputting based on string length. And remember that string length will always include the sentinel value. So whenever we think about this, how would this output? We're basically just printing the string here. And I guess the question for you guys then is, do you think X is a valid string like this?
Yeah, won't it automatically add the sentinel value?
Yep, exactly. No, perfect. Because whenever we declare a C string like this, it'll always incorporate sentinel value. So the size of the string is actually going to be 6 because it has HELLO, and that's going to have that sentinel value at the end like this. So what's going to happen is it'll keep reading HELLO, and then it will stop after this. So we're good. Doesn't string length not include characters? Yeah, string length does not include characters. It only includes like the base address, or sorry, the characters we actually have inside the string. But our compiler implicitly has a sentinel value here like this. But we just don't consider it in our string length function. It's implicit, yeah, exactly.
So I guess like a follow-up to that is if you just swapped out X for Y here, you replace everything with Y, would it still print normally too?
Actually, let's test that out. It's a great question. I'm not 100% sure on that. So let's just go ahead and go into this for int I equals 0, I less than, I have to include string length of Y. Go ahead and see out. Let me rerun this. Yeah, we'd have some bad access happening here. Again, because what's happening here is that our compiler isn't sure like how to treat the length of Y in this case. So it's outputting, again, like it's outputting the characters that are past O, and it's not sure how to handle that. So if we were to add the sentinel value in, it would fix everything. But we didn't, so that's why we're having errors with it. This question basically is testing you guys on whether you understand C strings and how you need this in there if you declare it like this. That's the big takeaway from this question, is you can declare it like this. That's all good. If you do it like this, you have to add in this value.
Okay, I guess is it like fair to say then that the string length function works because of the sentinel value, like it?
Yeah, exactly. The way the string length function works, I can go to code and type it real quick. So basically, the way string length works is that it'll take, I'll say int string length, and it takes in a const char pointer like this. We'll call it str. And the way this works is that we're going to read while str. What this means, again, is basically saying while we're looking at a valid character in memory, we're allowed to go into this loop. And I'm going to have a thing called size up here, set equal to 0. And I'll say size plus plus. And then str plus plus. So what I'm doing here essentially is I'm looking at the string. I'm saying, is the current character valid? If it is valid, I'm going to add 1 to the size and have it point to the next character. So in that string where we had it where it's like hello, like this, what's happening is my str is going to point to H. And then I'm saying, okay, cool, H is the valid character. I'll then point to E and increment size by 1. And then it'll keep on going until it reaches this character. Once I'm at this, it'll break this while loop, and then what's returned down here. So let me add that in. We'll just return size. Like that. And then if you want to make this code compact, like if you wanted to, you can always do a post increment here. This basically is just going to say, after we read the string, go ahead and increment it. So I can get rid of this, and then there's that.
Cool, thanks.
Yeah, of course. All right. Let's go ahead back to this. All right. Here's some argc stuff we can cover real quick. This stuff is not too terrible. So let's go ahead and get started on this. And I think this also works with pointer arithmetic, so this is good stuff to review, because I know on the exam, they'll sometimes ask you guys, oh, go ahead and solve this question, but you have to use pointer arithmetic and stuff. So it's important that like you understand like the difference between like traversal by pointer versus traversal by index. So I think we have some slides on that back in the drive and stuff. So if you want to review that, definitely go ahead and do that. So let's see. The first question, we always enter in this. So the first thing I want to do here is just like talk about like how many arguments we have. So we have 5 arguments. So argc is going to be 5, which means for argv, we can only access 0 to 4, like that. So we're given 2 files. This is always going to be included as arg0. That's basically just going to be the name of what we're running. And then this is always implicitly inside our argv array. So the first question is, what is the output of the first cout statement? Here we're just given argc and argv. So here we're outputting argv plus 1. So going back to our previous discussion, we talked about how argv pointer argv like this is equivalent to, sorry about that, argv is equal to like this. These two are equivalent. So think about argv as being an array. So going back to that, argv in our arguments, argv points to this. It points to myprog.exe. So this is argv. So if we add 1 to that, we're using pointer arithmetic. And all we're doing is just going forward to the next argument right here. And then we dereference it. So again, we go to right here, and then we dereference that. So that's going to get us the value of file1.txt. Any questions about that? All right, good stuff. What is the output of the second cout statement? So this is interesting. So what's happening here is this is using array, what is it called? Array syntax. So I'm going to convert this into pointer syntax so we can get some more learning out of it. So the first thing we have to notice here is that we're accessing the the third element in argv. So we know that argv is equal to all this stuff. So argv of 2 is going to be file2.txt, right? It's the third argument. And then we're accessing the 4th character of it. So the 4th character is 0, 1, 2, 3, 4, which would be 2. The one thing I want to talk about here, though, is like, what does this mean in terms of pointers? Because this could appear in the exam, and it's a lot more confusing. So if we wanted to output 2 as well with pointers, how could we do that? So this statement up here, argv2 of 4, this is equivalent to this. Argv, we saw in the first example, if we wanted to get the second argument, aka file1.txt, we added 1 to it and dereferenced it. So in this case, we can add 2 and do this. This will get us to the third argument. This will get us to file2.txt. This is the exact same logic as the first cout statement. Now, if we want to get the fourth character in this, or the 4th index, or the 5th character, the 2 here, what we do is we add 4 to it like this, and then dereference it. This is the exact same as saying that. Because at the end of the day, arrays are just pointers under the hood. So whenever you work with arrays and you do this notation, your compiler will think of it like this.
Wait, could you explain that one more time?
Yeah, sure. So basically what I'm doing here is argv plus 2. That right there is getting us to our second word right here. This being the 0th word, the first word, second word. That'll take us to the string file2.txt. Once I dereference that, I'm accessing that part of memory. Then when I add 4 to it, I'm saying go forward 4 positions. So 0, 1, 2, 3, 4, and that'll access the 2. Now, I have this dereference here that says only read the 2. That means give me the object in memory at 4. for this string right here. Now, a fun fact here: if I got rid of this in order to output it, it would actually give me 2.txt. But if I add in this dereference, it'll just give me 2. The reason being is that you can think about when we read out C strings, right? Like from the example down here. Whenever we outputted dereference y, we're only reading one character. Same thing here. Since this is going to be a char pointer, it's going to be a C-style string. If I dereference this, I'm only going to get one character. If I don't dereference it, I'm going to get everything in that string after the 4th index. So I'll get 2.txt. I can go over it again if you guys want. I know it's a bit confusing, but any questions about that?
Yeah, I just had a quick question. So
Yeah, sure.
would the 5th index be that dot, or would it be the T?
Oh, the 5th index would be the dot.
Okay,
Yeah, because the dot's going to be treated as a character as well.
gotcha.
Yeah. So yeah, like the big thing here at least is that argv plus 2 dereferenced. Since argv is going to be, you can think of it like as a base pointer, right? This is pointing to each word. And whenever we add one to it, we're going to go the next word, and then the next word, and then the next word. Once we do that and dereference it, we're locked in at looking at this right here. We're looking at file 2.txt. Whenever I add 4 to it, I'm going forward by 4 characters to 2. Whenever we output a C-style string, it's either going to output one character or all the characters, including and preceding that one, based on if I dereference it or not. If I dereference it like this, that tells our compiler only read the single value memory at this address, which in this case is going to be 2. If I don't have this, it says read everything, including and after it, for this given word. So it would output 2.txt. And again, if I change this to a 5, I would only output dot. If I made it a 6, I would only output t, so on and so forth.
So if so, looking at the first cout statement, if you were just to see out argv plus 1 without the asterisk, what would that print?
If you're to output argv plus 1, that would go ahead and would output the first word.
What would it print?
Oh, argv plus 1?
Yeah.
This would output... it would output like the address, I'm pretty sure, because argv plus 1 is going to be the address of the first word. If you want to go ahead and get the first character of the first word, you would say argv plus 1 dereferenced like this, and then you had to do this.
Okay.
Yeah, that would give you the first word, or sorry, first letter of the first word.
Okay.
Because there's an adding an implicit 0 here. Yeah. It's a bit confusing because like if you want to output the address, you would just put like the address operator instead of the dereference stuff. But you probably wouldn't need to do that for any reason. Because C-style strings are a bit wacky like that, where they like break conventions for other pointers and stuff. All right, move on now. What is the value of argc? All right, this one should hopefully be pretty easy. We have 1, 2, 3, 4, 5 arguments, so it should be 5. Any questions there? No, okay, perfect. This question plays into what we talked about earlier. What is a different way to declare argv? So I'll also explain it one more time. So argv, we can do it like this. Pointer argv, or we can do double pointer argv. And intuitively, this should make sense. argv is a pointer. All arrays are pointers under the hood. So these two should be equivalent, right? Because all I'm saying here is that this argv is a pointer, a double pointer, right? Because you can think of it like this. In memory, we have like argv 0, 1, 2, 3, and 4. And those all point to different words, like /my program, right? If I have like /my program. And then argv2, if you dereference it, you get the entire word. And then if you want to get a certain character, you dereference again, and then you get that character. Does that like conversion make sense to you guys? Why these two are the exact same? It's just pointer decay at the end of the day. would char pointer argv be equivalent? If you did like char pointer argv like that?
No, like if you had the pointer before char instead of after
Oh,
char.
I think I've never done it before because I was always taught to declare it like this. But aren't these the exact same if you do like int x versus like int pointer x?
Yeah, that's what I was thinking. But like I also have only seen it with the asterisk.
Yeah. If it works for ints, it should work for for char pointers and stuff.
Okay. Gotcha.
Well,
Thank
it
you.
is an option, so I guess not because the correct answer is this.
Well, because also.
Oh yeah,
like,
because that's there. Yeah. Okay. That's a good question, actually. I mean, I assume it would work. I don't see why it wouldn't work, but yeah, I assume that'd be the
Okay,
exact
thank you.
same. Yeah, I mean, intuitively it makes sense. And then, okay, cool. That's all that. So we can now do true and false, and then we should be able to go through any questions you guys have. So let's try to mark these out as fast as possible. All right. Any more questions about these two questions? I know they're like pretty intense in terms of like pointers and stuff, but it's good practice. All right, cool. All right, let's get started. So public class members marked as static can be accessed without referencing any particular instance in the class. What do you guys think? You can just unmute if you want to answer the question.
True.
Yep. Why do you say true?
I don't know.
Yeah, I mean, it's just a fact. Yeah, absolutely. Like that's how it's defined. That's how static's defined. So yeah, that's how it's defined in C++. So it's true. A lot of these questions, like there's not much explanation needed except for like these questions down here. But a lot of these are like, oh, it's a fact versus not a fact. So it's just good to have in your tool belt for the exam. Okay.
I'm guessing if the variable was marked static and in the private section of the class, would it this would be false, I'm guessing?
Yeah, because if it's private, you have to use a getter function to access it. All right, consider the following two lines of code. Int a equals 2, and then in order to, the type should be int pointer. So what you guys think about, like, what is this doing right here?
Oh wait. Usually it's like int star x, right? And then the address of a. However, it's moved on the other side, so we wouldn't put the int star there anymore.
Yeah, so what's happening here is we're getting the address of a, and then we're going to dereference it. So it's like we're getting the address of a, but then we're saying get the value at a. So this right here evaluates a 2, actually. And so we can't have a pointer point to an integer. That doesn't make any sense. So instead we just say int.
So if we were to see it on that side, it would be first getting the address and then dereference.
On, sorry, the left-hand side or right-hand side?
On the right-hand side, sorry.
Oh, yeah, right-hand side? Yeah, absolutely. So we're getting the address, then we're going to go ahead and say get the value at a. So this is basically just 2.
Mm-hmm.
So we have an int here because we can't say like int pointer equals some value. That's not allowed. It has to point to some address in memory or no pointer.
What would happen if we did int pointer x equals dereference address of a?
Oh, we did int pointer?
Mm-hmm. What would happen if
What kind of error? It would be a type mismatch. So I'll go ahead and show you my compiler. It would give me a warning. So if I go here and I say something like int like y equals 5, and I say like int pointer x equals the dereference address of y. Yeah, it's right here, like a value of int cannot be used to initialize an entry for int pointer. So that's the error we're gonna get. So it's gonna be a compiler error, because if I try running this, it'll just yell at me.
Thank you.
So yeah, no problem. A big tip for you guys, Sorry, my headset turned off for a second. A big tip for you guys, though, is if you see questions like this, and it's saying, like, is it, and this will appear in the exam, it'll be like, is it going to be a compiler error, runtime error? Like, what's it going to be? If it's like a conversion issue, like right here, it's always going to be compiler error. If you're doing something at runtime, like, let's say, for example, I have, like, a vector of ints called, like, example, and it's, like, like 0 and 1. If I go ahead and I see out like example of like 55, that doesn't exist, right? My compiler won't yell at me. So you see right here how everything's good? My code will compile, but at runtime, like if I have like breakpoints here, right? I go ahead and do this. Code compiles. Everything's good, but when I get to right here, it's going to break. So the reason, like the big tip here for you guys is that if you're doing bad access for a vector or any kind of container, it's either going to be undefined or it's going to be compiler error. For arrays, it's going to be compiler error, and so it's same thing with vectors. If you're like traversing an array by pointer, though, it's going to be a undefined behavior, right? If I'm just accessing like bad access, like right here, it's going to be a runtime error. Are we getting true false problems in midterm? You won't have them explicitly stated, but they're going to ask questions like really similar to this on your midterm, where it's going to be like, what kind of like runtime error would you incur here? So these topics are so relevant. They're not going to ask it like exactly like this, but they're going to ask you questions that are very similar to this. So it's always good to go over. So doing ampersand dereference on its own wouldn't cause an error, and it would give the value of A. Yeah, it would give the value of A. So if you just replace this with an int, you'd be fine. Like if I went ahead and I did like int y equals 5, int x equals dereferenced address of y. That'd be good. If I were to see out y. This, I'll get 5. My compiler's messing up, but it should give me 5. Yeah, it'll give it 5, so that's good. Because yeah, this converts into an int, and then this is an int, so we're good. Just make sure whenever you're debugging this stuff, you have type match. So if you're comparing an int to an int, make sure they're both ints. And that's the biggest tip for you guys. Otherwise, these questions are just like, you can also throw it into your IDE. If it's like, oh, will this cause an error? Like what kind of error is it going to be? You can always just put it in your IDE if you have time and test it out yourself. But my rule of thumb is if you're doing bad access on like a vector, it's going to be a runtime error. If you're traversing with a pointer and you're going out of bounds, it'll be undefined behavior. So those are like the two big things there. Let ptry be a pointer double, then ptr plus equals 1 will increment the value of ptry by size of double instead of 1. Yeah, this is how pointer arithmetic works. Remember that if we're going to do traversal by pointer, what we do is, let's say I have int array like this. Int array equals 1, 2, 3, 4, 5. And I want to output the values using traversal by pointer. I would go ahead and I'd have a for loop. I start off by saying int ptr equals array. Like ptr is less than arr plus 5, ptr plus plus. And then I'd like output this. So what's happening here is I'm making ptr equal to arr. ptr is going to point to the first element in this array, so the 1 right here. And whenever we add 1 to this, it's going to implicitly go forward by an int amount each time memory. So I'll go to a 2 instead. It just depends on the type you're working with. So for int, it's going to be 4 bytes. And then for double, it's going to be 8 bytes. So yeah, this format, you're always going to use it on traversal questions. All right. Consider the program with the 2 variables. Double b equals 3.14. Double, this right here, they don't talk about that much in lecture and stuff, but this is called an alias. So that means that C, if you have memory like this, if you have B with a value of 3.14, and we declare an alias called C, that means C also has that address in memory. So it's like the exact same variable has a different name. So these variables correspond to 2 objects in memory with distinct addresses. So distinct addresses. So that's going to be false because they have the exact same address. They're going to be referring to the exact same place in memory. Does that concept make sense to you guys?
One more time.
Yeah, sure. So basically, we have our memory like this. B will have a value of 3.14. Whenever we declare an alias with this operator, that basically means that C is also going to live at this place in memory. So that means if we ever call C and modify it, it's going to implicitly change the value of B, because B and C are, for all means and purposes, the exact same variable. They have different names.
Oh, so reference semantics.
Yeah, exactly. All right. A derived class inherits all public member functions of its base class, including the base class constructor. So yeah, this one's also going to be true, or say this one's false. This is going to be true. This is just like the definition of how a polymorphism works. So if you're confused on that, Peter went over polymorphism for like an hour yesterday in the review session. The recording's posted, so a lot of good resources there. All right. A derived class has direct access to private member variables of its base class. No, that's illegal. It doesn't have that. That's just, again, polymorphism states that it has access to public member variables, but private ones, it doesn't. You have to set those using a setter, or you have to call the constructor inside of your derived class constructor, right? If we have a base class like this, and we have some derived class up here, we'll call it D. If you want to set the value, if you declare an instance of a derived class right here, and you want to set the values in the base class, in your constructor for the derived class, you have to go ahead and set the values of the base class, either using a constructor or you can use a setter function, if they're private. If it's public, you're free to use them. All right. Although not all abstract data types are implemented as structs, all structs are examples of ADTs. And this is a bad question because I remember I took this exam, I said it was true, they said it was false, and afterwards they said either option's accepted. So we'll just throw this question out. It's a bad question, but because it's either true or false. Like you can look at it through different perspectives and arrive at different conclusions. So it just kind of depends on like how you view the questions. Why can't it be false? I believe that there are certain ways you can implement structs in which they aren't ADTs, but I actually don't know why it could be false because I put true and I saw the solution and I was like, that makes no sense. And then they made a Piazza post and they were like, oh, sorry about that. Either option expected. So yeah, I don't know. It's a bad question though. They just gave everyone points on it, so we'll skip it. All right. If P is a pointer type, the statement cout P is guaranteed to print an address.
False, because it could print out, if it's like a C string, it could print out a string.
Yep, that's a great reasoning. So that's a perfect example of one. Whenever you see questions like this, like guaranteed, just think about counter examples. Like we saw down here with where is it? C strings, right? If we just output like a C string, then it'll give us a value, not an address. So yeah, C strings are a perfect counter example to that. Okay. Procedural abstraction involves logically separating what procedures or function does from how it's implemented. That's true. Definition of abstraction. Abstraction is basically just like hiding complexities in functions, so we're good on that one. All right. The following two declarations are functionally identical. And I'll go into code for this because this kind of like ends our true and false section so we can do review stuff. I know some people want to talk about pointers and strings and stuff, so we'll do that right now. This is a great segue into it, actually, because this question right here will appear in the exam. Like they'll ask you guys, like, oh, if we did this, how could we change the pointer? So we'll go ahead and talk about the difference between these two, because they are a bit confusing. So let me pop up my Visual Studios. Let's say, for example, I have int x equals 5. So I'm going to go ahead and drop memory for you guys so it becomes a lot more clear. Let's say I have in memory x with a value of 5. I can go ahead and make an int ptr equal to the address of x. What's going to happen there is that, let's say this is at address 0x1000. That means ptr's value is going to be 0x1000. So whenever you refer to ptr, that's going to refer to x up here, right? So we have no constraints. But what would happen if we added in a const right here? Well, let's think about what this means. This means it's a const int. What that means is that I can't do this. I can't say dereference ptr equals 6. So we get an error right here. The issue being is that if we have a const keyword right here, that basically says, okay, we're allowed to change what PTR points to. That means PTR, we can change this value to, let's say, I declare a variable called y right here and say int y equals 10. I'm allowed to go ahead and say PTR equals the address of y. So all I'm doing here is saying instead of pointing to x, point to y. And I'll have y have a value of 10 with an address of like 1008, let's say. So I can do that. I can change what PTR points to. What I can't do is say, go ahead and change this to a 6. Because this const keyword right here is basically saying, I promise not to change the value of this memory address. But what I can do is just access different values in memory, but I'm not allowed to change them. I can also have something like this. I can go ahead and move the const right here. Notice here I get an error if I try to do this. What this is saying is that I'm allowed to change the value of the memory I'm pointing to. That means I can go ahead and say dereference PTR equals like 5. Or I guess like 12 in this case. That's fine, right? Because we don't have a const keyword here. That means I'm allowed to go ahead and change the value of x to anything, right? What I can't do is move what I point to. I'm not allowed to go ahead and just say, oh, go point to y now. I can't do that because I have the word const here. And the last case is if I had a const here, this means I can't do anything. That means I can look at y, but I can't change, sorry, in this case, I'm pointing to x. However, I'm not allowed to change the value of x, so I can't do that, nor can I change what I point to. So I'm forced to keep looking at this x in memory. I'm not allowed to change what I point to, nor am I allowed to change the value.
I just have a quick question.
Yeah, sure.
So if you have const int pointer equals address of x, could you change like x by saying like x equals like 3 or x equals 4?
Yeah,
but
yeah,
not,
absolutely.
not dereferencing the pointer.
So if I do like, let me get rid of this. If I do like x equals 22,
Yeah.
yeah, absolutely, you can do that. However, if I have the word const here, I can't do that.
Okay.
Because what's happening here is that if I have this x right here,
Mhm.
think about what I'm doing. I'm changing x implicitly. I'm saying, or explicitly. I'm saying x, you're 22 now. There's no like regulation here specifying I can't change it. For this pointer though, I'm saying this pointer, even though it points to x, I can't change x because there's a const here.
Okay.
Yeah.
But if you were to dereference pointer again, it would still print 22 like after. Because...
Oh yeah, we can. If I do this, like difference PTR, I'll get that. I should get 5. If I do this, I should get 22.
Okay.
Yeah. If I do this, again, my compiler is acting weird. But yeah, it should output that.
Okay.
Do I have breakpoints somewhere? No, I don't. Okay. My compiler is acting weird, but yeah, it should output 5, then 22. And then can you define something as star int pointer? I'm pretty sure you can. Let's see. Because you can't. Yeah, so you can't do that, unfortunately. So yeah, I was wrong. You can't do star int pointer like that. All right, so that wraps up the midterm exam. We do have 45 more minutes left, so I'm happy to answer any questions you guys do have. So I can launch a poll in a couple of seconds so we can vote on what we want to review, or we can talk out loud. What do you guys want to do? To the cheat sheet from yesterday. I don't believe we made anything for yesterday. I can go ahead and check on our drive. So, oh yeah, we do have some stuff. So right here, we have like pointers and reviews and stuff. I just made this, and then what else do I have? I can link this. Yeah, we have a lot of stuff in here. So let me link this to you guys. Oh, not that. There you guys go. And then the recording will be posted about like 8:30 or 9ish when it's done compiling. And let me go ahead and make a poll real quick for you guys. Pointers, arrays, C strings. Any other like review ideas? Post them in chat. I'll put them as a category.
Maybe like some traversal questions, like pointers and things like that.
Oh yeah, traversal, classes, structs. I can do a generic ADT. Because that falls. I'll just make it all one category. ADT, static. I can do that too.
Also with static, can we do dynamic as well?
Oh yeah, static, dynamic.
We do virtual functions also.
Yeah, sure. All right. And then I think you guys should all get the poll. Your polling session is inactive. I have not used Zoom. I might use straw poll, honestly. I haven't used Zoom polls in a while. Does anyone know how to like launch the poll? All right, straw poll it is. All right. Let's see. All right. We'll reconvene like in 2 minutes and then we'll start reviewing some stuff.
It only lets us choose one answer. So, did you do that on purpose or like?
Sorry, what was that?
It only lets us choose one answer at a time.
Yeah. I think we should just like vote on whatever you guys think is like the most important for you guys, and then we'll go over like I want to try to do like most of these obviously because I think we have time to do like all of them, but just click the one you think is like most important to you.
Got it. Thanks.
The first question, multiple choice. Yeah, sure, we can cover that real quick while the results come in. All right, so. Was it this question you were referring to? No, the first section. Oh, true and false? Oh, 0A. Yeah. Okay. So yeah, public classes marked as static can be accessed without referencing any particular instance of the class. So yeah, this right here, it's going to be true. That's just how static functions or static member variables are defined. Since it is public, we can't access it because they are public. If it's private, then we couldn't do that. All right. I'll give you guys like 30 more seconds to answer this. We have 20 responses and 30 people here, so give it a couple of questions. And yeah, I can cover all of these in like 40 minutes, so we should be good. All right. So for the 60 guys who answered pointers and arrays and the 4 who did traversal, those are kind of the same category, so that's like half you guys, which is pretty good, so I'll cover that first. And then I'll go ahead and cover classes. These 3 are pretty related to each other, so we can cover both of those. And then exam tips. I can cover that like, I can do it right now, actually. That's pretty easy to, I don't think new and delete are on the exam. You don't think so. Did they confirm that somewhere? I'm pretty sure it should be on the exam. It's pretty crucial to polymorphism. If it isn't, that's good for you guys, but I'm pretty sure it is. Oh, they aren't. Okay. So, yeah. That's good. Okay. I thought they were. I mean, they have been for the past, like, couple of exams, but that's good. So, we'll start with pointers and arrays and traversal. So, typically, for the pointers questions on the exams, they're typically going to revolve around an array in C strings. So there's two options here for response questions. It's either going to revolve around, oh, you're given a C-style string, we need you to modify the string in some way and return its output. We saw this in question, let me pull this up real quick. Yeah, we saw this in question 1.1 right here, where we had to modify a string. So we'll go ahead and just talk about this a bit more in depth and sort of like what's expected of us. So with pointers, I'll just do a high-level overview real quick. So with pointers, at least, what's happening is that in memory, they always have this diagram, and people get confused, like, what does the diagram actually mean? You can think of this as, like, sequential objects that are stored on your computer's memory. Every object has 3 things associated with it. It has some name. So I'll go ahead and make a basic example. We'll do int x equals 5. What's happening here is that there's some variable x, which refers to some memory address. Memory addresses are denoted as this, 0x, that means hexadecimal, which is base 16. All memory addresses are denoted as this. After that, there's going to be a bunch of numbers. So in hex, we have the range 0 to f, because we use base 16. So memory address will look something like 10, like FE69, right? Like that could be an example of a memory address. So we'll make it simple for this example, and I'll just say it's 0x1000, which means in memory, x's address is going to be 1000. I'll put that right here. Every variable also has a value associated with it. So in this case, x's value is going to be 5. If we just said int x like this, there would be no value there. It would just be randomized, essentially, because we haven't initialized it yet. So we put 5 here. That means 5's going to be the value of x in memory, like this. Going forward off of this, what pointers do is if I make int asterisk ptr equals the address of x, what's happening here is I'm declaring in memory this thing called ptr. Its address, we'll call it 1004. And it'll have a value of x's address. So the pointer's value is going to be 1000. So the pointer is literally going to store x's address in memory. So that's how pointers are defined. The big idea for the exam, though, is how do you do traversal? So if you understand that, the next hardest part is going to be traversal. So if you're ever traversing over, we'll do an array real quick. Let's say I have int array equals 1, 2, 3, 4, 5. If I wanted to traverse this by pointer, this structure holds for every single traversal question if you're traversing a array of non-chars. So any sort of array of strings, array of ints, array of doubles, etc. What you want to do here is have a for loop. And what I'm going to do is I'm going to make a pointer in here. So int asterisk ptr, I'm going to set that equal to ARR. The important thing here is that arrays are essentially pointers under the hood. So this array right here, the way you can think about it is that we have the values 1, 2, 3, 4, and 5 in memory. And array, ARR, this is a pointer to the first element in that array. So let's say ARR has the value, its address is going to be 1000. That means 1's address is going to be 1000, like this. Arrays are defined different than vectors. Arrays, their size has to be known at compile time, and also all of their objects, or all of the members of the array, are going to be sequential in memory. What that means is that 2 is going to be 0x1004. and 3 is going to be 0x1008, so on and so forth. So when an array is laid out in memory, these addresses are also going to be consecutive. That means if we are traversing by pointer in this case, what's going to happen is that we can always just increment our pointer forward by 1. And that'll change it from pointing to the first element to the next element, so on and so forth. So in this case, what we want to do here is say, traverse this 5 times, because we have 5 elements. But we don't know, like, what's our stopping criteria going to be? Whatever PTR is a memory address. So PTR's value is going to be 1000, right? Because PTR starts off by pointing at ARR, which is 1000. So what I'm saying here is, while the memory address of PTR is less than, we can say ARR plus 5. ARR plus 5 is going to be this right here. And this is going to be some memory address. We'll call it like, I don't know what 1000 plus 20 is in hex, but it's going to be some number. We'll just make it like 1020 for simplicity, right? It won't be this because hexadecimal uses base 16, but just for like learning, we'll use it like this. What this is saying here is basically iterate through this until we reach this address, which is going to be 5 over. So once we do that, we're done reading it. To increment a pointer forward, we'll say PTR plus plus. This basically is saying go to the next element in memory. And it will always go forward by how much this pointer is of a type. So since it's an integer, integers are 4 bytes, so it'll go forward by 4. We're traversing an integer pointer, an integer array, sorry, so we're good to go forward by 4. And then inside of this, we can work with our array. So to get an element of the array, we can go ahead and just dereference our pointer, and that'll give us the value we're pointing to. That's the basics of traversal by pointer. I'll open up the floor to any questions you guys have about pointers, because you probably have some like specific questions. Okay, if before the loop you do something like ARR equals 6, would that change 1 to 6? So ARR against a pointer. So if I do like ARR equals 6, that would give me an error, because ARR is going to be a memory address. If I want to change the value of the 1 to a 6, I can just do this. And then if I see out ARR, it would give me the value of 6. So what's happening here is that ARR, remember, it points to the first value memory, and we're implicitly saying this plus 0. If I want to change, let's say I want to change a 3 to a 9, I would say plus 2 and put a 9 here. And that would go through and it would say ARR plus 2, so plus 1, plus 2, change this to a 9, and then we're chilling. That's the idea behind arrays. The big takeaway from arrays, at least, if you get one thing out of the session, is arrays are just pointers under the hood. Arrays are literally just pointers. We have fancy syntax. So we have syntax like, what is array of 2 equals 5? That's the exact same as saying this. Those two are identical. And then 2D arrays, those are a bit more confusing, so we'll do that right now. A 2D array, I can have something like int array of 2 and 5, like this. And then I could define it like, I'm gonna get 2 by 2, just to make it easy. All right, so 2D arrays, we saw this before. We saw this with this question right here, and we also saw it with the argv question. So remember how argv is a double pointer? Argv is like this. So this logic follows through. What's going to happen here is that if I want to access, let's say I wanted to see out array of 0, 0. In pointers, how I do that is I would go see out ARR plus 0. That right there, what's happening is that that'll get me to the inner matrix. It'll give me to this thing right here. This is ARR of 0. If I want to access this 1, that's the 0th index of the 0th array. So I then add 0 like this, and I would then dereference it again. And that would give me the value of the first array. So the value of, why is this mad? I probably declared it wrong, but But yeah, so essentially you'd output it like this. And that would give you the value of this 1 right here. Oh. Thank you. Okay, there we go. Okay. That works now. Okay. So what other questions you guys have about pointers I can answer right now? It could be anything, like related to the exam or just anything in general with pointers. You can type them in chat, or you can just ask out loud.
So wait, in that for loop you have above where it has ARR plus 5, that's gonna check like the first 5 indexes of the array, right?
Yep, exactly. And why is that?
Because ARR itself is the first one, and then it goes 5 after. Or
Yep, exactly. So what is ARR in this case? Is it going to be like some value, or is it going to be a memory address?
a value.
It's going to be a memory address.
Oh,
right?
okay, my bad.
Yeah. No, you're good. You're good. It's always good to ask these questions because like it validates your like learning and stuff. So like right here, remember that we have 1, 2, 3, 4, 5. We have 1, 2, 3, 4, 5. ARR is going to point to this. It's going to have some 0x address, right? If we add 5 to that, we're going to say 5 integer locations later. That's the address of that. So it's going to be right here. What we're saying is, whenever we're reading this, we want to keep on reading. So our PTR value is going to hop like this. This is going to be PTR. It's going to keep going forward in memory and keep reading these addresses. Since arrays are sequential in memory, this makes logical sense, right? Because we can just go forward by one memory block at a time. And since it's sequential, this ARR plus 5 is basically saying, stop. Once you get to this, stop reading, stop doing stuff. That's what's happening there. Sorry, what was that?
And it only does that because an array doesn't know where to stop on the phone.
Yeah. So basically, the reason this works is because an array is a fixed size, and PTR is going to either point to like one of these, right? PTR, we're going to traverse through this pointer, which means we're going to change what element it points to. We're saying PTR is going to start off at array, right? PTR, I'll make this a different color so it makes more sense. PTR is going to start off at this memory address, the memory address of ARR. ARR's memory address is going to be the address of this 1 right here. ARR plus 5 is going to say 5 memory addresses after ARR. So 5 memory addresses after ARR is just going to be right here, which happens to be the end of our array. That's exactly what we want. All we're doing here is saying 5 because the size of our array is 5. There's no way to know the size of an array because there's no function for that. But whenever you have to work with them, typically you'll be passed in like int the array, a pointer to it, and you'll also be passed in a int for its size. Does that make sense?
Yeah.
All right, good stuff. All right. Yeah.
So on that last CL statement, so it has the inside, the first parenthesis says star array plus 0.
Yeah.
That'll print 1, 2.
Yep.
And then the fact that you're doing plus 0 again will only print 1.
Yes.
Okay, gotcha. That makes sense.
Yeah. This right here would print out the first array, and this is specifying print out the first character.
Gotcha.
But yeah, I think in one of the cheat sheets we have on our drive and stuff, we outline like this is the format you should use for traversal by pointer. And then if you're doing index, it's really easy. You just do like for int I equals 0, I is less than 5, I plus plus, and then we'd see out. I want you guys to think, and if it's not clear, please speak up because I want this to make sense. These two, if I do see out, these two are the exact same thing. They are doing the exact same thing at every single step. Does anyone understand, like, does anyone not understand why these two are doing the exact same thing at every single step. And it's fine if you don't. I want to make sure this makes sense to you guys because this is like really important for the exam. Does anyone, is this fuzzy to you guys? To anyone here?
For the traversal by pointer,
Mhm.
how come you see out star PTR rather than star ARR?
So look here and see how that PTR is pointing to array. We're incrementing PTR every step. ARR is always, so I bring back this block of memory. We see that ARR is always going to be pointing to the 1 here. It's always going to point to the address that holds the 1. Notice that we're never changing ARR in any of these statements. All we're doing is saying we're going to start off at ARR. So PTR is initially going to point at the starting point, right? This is like saying I equals 0. We're just saying start at the beginning of our array, which is this. So these two, this right here is saying start at the beginning of our array. This right here is saying go until the end of the array. Notice here how we never actually change ARR's value. We're never saying ARR plus plus. We're never saying ARR do this. We're always incrementing PTR here. We're always changing what PTR points to. We're saying PTR plus plus. That means PTR after this, now you point to 2. PTR plus plus, now you point to 3. We're never changing what ARR points to. Does that make more sense?
Yep, thanks.
Yeah, of course.
So I have a question related to like traversing C style strings. Like I have in
Yeah,
my
sure.
like for the for loop, it says like const char star PTR equals whatever.
Mhm.
And then the second like part of the for loop, it just says like PTR. So I'm kind of confused as like what.
Oh, yeah, that's a good question. So this is like more like semantic stuff that's kind of confusing. So I think this function, this is the exact same thing you're asking about, right? Where we have like while str. I think that's right
Yeah.
here.
Yeah.
Okay. So let me ask you this. What is str in this case? Like what does it evaluate to?
When you dereference it, it'll get a character.
Yep, exactly. And what happens when we get to the last character in a C string? What should that be?
A null character.
Yep, exactly. And if we ever, it's like that, I think. Okay. If we ever get that, what happens is that our compiler will interpret this to be false. Whenever your compiler sees that or null pointer,
Mm-hmm.
it interprets both of these to be false. And if I have while false, will the loop execute?
No.
Exactly. So a better way to put this, just so it's like more explicit, I could say while this does not equal sentinel value.
Gotcha. Okay.
So that is equivalent to this.
Okay.
Yeah. It's a good question though. But if you write it like that, like this, you won't be wrong. Like this is completely right. Like that. There we go. That's completely valid. You can do that too.
Mhm.
I'll just do like that. So that's what's happening there. We're basically just checking, are we pointing to a valid character? If we're ever pointing to the null character or the sentinel value, we'll stop reading our string basically, is what happens.
Gotcha.
All right.
So this string length function's like useful for when you can't use like the str length. Like
Yep, exactly.
Okay.
So if you guys want, go ahead and you can screenshot this right now and then use it on your exam.
Okay.
If they ask for it, because again, I'm not sure of the specific rules this time, but I know when I took the class, you were allowed to go ahead and just like use the internet. I'm not sure if the rules are the exact same, so not endorsing Googling anything, but you can have cheat sheets, so put that in your cheat sheet. Because that's how string length works.
So essentially, the null character like terminates the while loop.
Yep, exactly. Because it evaluates a false. Same thing with null pointer. If I were to pass in a null pointer here, it would evaluate to false. And then when you guys do project 4, you'll do more stuff with like pointers and like null pointer and stuff. A string type variable can be passed in as a parameter, not just a C string. A string type. I believe so, but this functions for const char pointers, and if you pass in a string, I think that would still work because a C style string and a string are under the hood the same thing. I doubt they'll ask that though. I'm not 100% sure on that, so I won't give you a wrong answer. But I wouldn't worry about it. All right. Any more questions about this stuff, guys? I'm happy to stick around more for this because this is like half the exam right here. So this stuff is pretty big. I'll give you guys like 30 seconds to think of any more questions. Otherwise, we'll move on.
Is this review going to be like recorded?
Yeah, it's going to be recorded. So we record all of our reviews and we put them on the sheet right here. So we have yesterday's recording up right here. There we covered like the majority of the exam. Let me just go ahead and post this in here. Yeah, I'll post it like tonight at like 8:30 or so whenever it's done recording.
Okay,
Like,
thank you.
Yeah, of course. If you have to edit the array for the for loop, would you do ptr equals x or ptr dereference equals x? The array in the for loop. Do you mean like edit the value of the array, or do you mean edit like what the array points to? Edit a value. That's a great question. So think about like this. Right here, when we do cout ptr, are we outputting the address or the value? Yep, exactly. So if we do this, that means we're going to change the value. So dereference ptr. Let's say we want to change it, everything in the array to be 7. This is the exact same as saying this. And I want you guys to like understand these two are the exact same thing, because this really helped me understand pointers. Pointers are really confusing to me. But once I looked at these like similarities, right? These two functions are doing the exact same thing at the exact same step. Every iteration is doing the exact same work because, again, this is just this under the hood. They're both doing the exact same thing. So here, when I say ARR of I, I'm really saying change the pointer value to 7. It might look different because obviously there's more happening here, but they're doing the exact same thing. All I'm saying is PTR some address in memory. I want to change that. So dereference that value and change it to 7. Any other questions about like pointers and stuff? Relatories and pointers, can you go over fall 2019 question 2A part 3? Yeah, we can do that real quick. Go ahead and pull that up. Okay. A. Yeah, that's a great question. This is a great one to conclude our pointer stuff with. So basically, let's draw out memory here. Whenever I see pointer questions, I instantly draw this diagram. So we have A is 42. So let's put that in our memory. A is 42. We have PTR points to the address of A. So that's proper semantics. That's good. So PTR is going to hold some value here. Is it going to hold A or is it going to hold the address of A? It's going to hold the address of A. So let's say that A's address is 0x1000. It's a bit sloppy, but play with me here. 0x1000 is going to be the address of A. So we're going to put 0x1000 in for here. So the next line says int dereference some alias equals PTR. So this can get a bit confusing because you see this and you're like, get the address of P, then dereference it. Don't think about that. If this is on the left-hand side, this alias right here, this basically means it's an alias. It has nothing to do with addresses. If you see the ampersand on the left-hand side of the equal sign, that means we're making an alias. So here I'm making an alias for PTR, and we're calling it P. So PTR is an int pointer. This is also an int pointer. This ampersand, all it means, it's an alias. So whenever you see this, don't think about addresses. Think about it's an alias. However, if this is on the right-hand side, then that means address. So here we're making some alias P, the same as PTR. So we can think about P as also being PTR. Does that concept make sense to you guys? Any questions about that? It's pretty confusing. So just, if it's confusing or muddy, let me know, please.
Yeah, I was just confused. So are you saying that basically it's another pointer?
Yeah, exactly. Yeah, exactly. So you see how PTR right here is an int pointer?
Yeah.
So this on the left-hand side, if you see the ampersand, that means it's an alias. Do not think about address if the ampersand's on the left-hand side of our equation here. Since this is also an int pointer, right? And this is an int pointer, that means that P is also going to be an int pointer. Aliases basically say this P is going to live in the exact same spot as memory, and it's going to do the exact same thing as PTR. So P, you can only think about this as P is also in here. So P or PTR is going to have this value in memory, and they're both going to, P and PTR are both going to be in the exact same place in memory. So if it was like ampersand P equals PTR, would that change it? Yeah, that'd be wrong then. So what's happening is that we have to make sure we have a type match. Since PTR is going to be an int pointer, so all the way up here, PTR equals an int pointer. Oh, that's really skinny. 1 second. Okay. So PTR is going to be an int pointer. If we're making P an alias to this, it has to match. That means this P has to be an int pointer. So when we say int like this, that means P is going to be an integer. However, PTR is an int pointer. So this would not work because we want to make sure it's an int pointer. They have to be the exact same type. This ampersand is just saying, oh, it's an alias, right? That means that this has to be the exact same type as this. Since PTR is an int pointer, and we said, oh, get rid of this pointer, it's just going to be an int. We can't do that. They're different values, but same object. No, they're the same value. An alias is defined as being the exact same thing. You'll never use them in code, they're just testing you on it. They're different variables? Yeah, different variables, but the same thing. They both represent the exact thing in memory. They both have the same memory address, and they both point to the same thing. Is int and b equals ampersand a the same as int b equals ampersand a? I think you said the same thing twice. So what you're asking basically is if you have like a like this, that'll give you an address, which means this has to be a pointer. So if you do like an integer equals an address, that doesn't work. Would int p equals PTR? Yeah, it's completely fine. Exactly. So if we got rid of this reference thing, so if we just said this, that would be fine. What would happen then is P would not be here. P would just be right here and have the address of 0x1000. So notice how the alias basically just merges these two together. If there's no alias, it's this. If there's an alias, they both are the exact same thing in memory. They both live at the same place in memory, and they both point to the exact same thing. So, sorry, go ahead. I heard someone unmute for a second. You can talk.
Yeah, that was me. So if pointer is a const, and then we have p, which is a reference or like an alias for pointer, does that mean that p is also const?
Yeah, but we have to include that's a great question. If this is a constant like this, like const right here, this also has to be a const. So whenever you declare an alias, they have to be the same type. There has to be type match, right? So if we're saying P is an alias or PTR, that means that P has to have the exact same words over here as PTR did.
And then also, does the const also have to refer to the same? So like if pointer is like a constant pointer to an int, then P has to be also a constant pointer to an int versus like a pointer is a pointer to a constant int.
Yeah, exactly.
Okay.
It has to be the exact same type at the end of the day. Yeah. So it's confusing, but the big takeaway from aliases is that if you see, so if you guys, again, it's all confusing, I'll summarize it in a couple seconds. What's happening here is that this alias right here is basically just telling us that this P is going to be the exact same thing as PTR. They're both going to have the exact same address in memory. The only difference is that P and PTR are different names. Otherwise, they have the same value in memory. They both point to the same thing. They're both like arguably the exact same thing. So whenever you declare these like in code, they have to have the exact same type. So notice here how this is an int pointer. This is also an int pointer. So we have type match. If we were to add const for this, so it's a constant pointer, then we have to add a const for this. They have to be the exact same type. The alias has to be more restrictive though, right? Like int star pointer equals address A and const int. Yeah, it wouldn't work. Oh, it would work. Let me look at that. Sorry, my mic got muted again. Yeah, they have to be the same type if you're declaring a alias like that. All right, so let's move on from this. And then, yeah, we go ahead and we pass in P. We know that P is the exact same thing as PTR. So we're effectively just passing in PTR. So you can get rid of this line and think about we're just passing in PTR. So this is PTR right here. When we pass in PTR, we're making a new pointer called B, which is equal to A. Since PTR is a pointer, we can do that, right? Because int B is a pointer, and we're setting it equal to a pointer. That's completely fine. And we're then going to output the value of B. B points to the same thing as PTR. PTR points to A, so we get 42 at the end.
Then what is that plus plus doing?
Yeah, it's a great question. So the plus plus right here, this is incrementing the value of B forward by 1. So after this executes, A is changed to 43. But because it's a post increment, what's happening is that we're outputting the value at B, and then we're going to update it. So what's going to happen is we output 42. After that, 42 is then changed to 43. So if we added the plus plus right here before it, we would output 43. But because we're doing a postfix, that means that we output it and then we update it.
Got it. Thank you.
Yeah, of course. All right. One other thing I wanted to cover real quick. Go over part 3. Yeah, sure. I was just going to do that actually, because this involves pointers and memory and stuff. Maybe it's this one? Yeah, it is. Okay, perfect. So this is some struct work, and then after this, we're low on time, unfortunately, so I'll just cover some exam tips, then we'll call it a day. But I'll cover this real quick, because this is also like important stuff. So basically, whenever you're working with pointer... Sorry, go ahead.
I meant like part 3 for the 2A.
Oh, cool. We'll do both of those then. Okay, part 3. So yeah, this is pretty similar to a question we did earlier today. So what's happening here is that, remember that if we output ARR of 1 plus 2, what we're really doing is we're outputting ARR plus 1 dereferenced. Notice the plus 2 here. This plus 2 means we're just going to do plus 2, and there's going to be no dereference operator here. So what's going to happen is that telling our compiler, go to the first word, so ARR plus 1, that's going to get us to world. Plus 2 says go forward 2 characters, so W to O to R. That means read everything from R onward. So we're going to output RLD. If we added this right here, we would only output R. And we see that exact same thing happen in the next line. So in the next line, what's happening is that we go ahead and we go ARR plus 2 dereference. That's bringing us to lobster. And then we're saying 4. That's the same thing as saying ARR plus 2 dereferenced plus 4 dereferenced. And that'll just give us the single character of T. Yeah, it's like exactly. Because remember that this is a char pointer, a const char pointer. This is an array, but arrays are pointers, so it's a const char pointer. argv is also a char pointer. So it's the exact same concept as before. Got it. Good stuff. Okay. And then I know people want to do structs as well, so we'll cover that real quick. So the big thing of structs is that the one thing they always like to do here is they like to work with pointers in these. So I'll go ahead and cover like the semantics of this and then some general strategies. So in the first question, I think you guys have all seen this question from last time. I'll talk about the pointer context. So notice that right here, we have an array of songs called songs, and they're working with pointers. Don't be scared by this. This is actually a good thing. Recall that arrays are just pointers under the hood. I keep saying that because that's like the big concept of this exam, is that arrays are just pointers under the hood. So if they're passing you a playlist, right? If they're passing you a playlist pointer, then you can always work with that in the context of arrays. That's the big takeaway from these struct questions, is that they're really easy to work with as long as you understand that pointers are arrays under the hood, because we have arrays implemented here, and we make an array of playlists eventually, I believe. That's the big takeaway from structs with pointers inside of them.
So wait, when we do problems like this on the actual exam, should we like copy paste all the different other things like the struct playlist, void playlist, add song, all this stuff?
Yeah, that'd be a great idea. The only issue is that you can't copy and paste in Crapster because it's like a PDF. It's basically, the reason they do it is because like some people will like paste the entire solution to like Chegg and the last one to solve it for them. So they don't want people to do that. So don't do that. They also have like technology enabled to where like everyone's exam has a unique background on it, so that if like you do post it on a website asking for help, they can determine whose exam it was. So just big takeaway is just don't cheat. It's never worth it, from that at least. But yeah, copying and pasting would be a good idea because like it would help you out a lot, but they don't allow that, unfortunately. I mean, you physically can't do it. It's not like against the rules. You just can't do it. Like it's a PDF.
Yeah, I mean just for like the implementations of these things, like.
Oh yeah. That's a great point. You can. It's really time consuming because you are having to like add all these functions and stuff. My advice is like for the first couple questions, right? Like this, you can easily go into Visual Studios and like type it up fast, right? You can like do that pretty fast. Since these questions aren't dependent upon like a struct or a class or anything, I would highly recommend going ahead and just putting the interior Visual Studios or your IDE of choice. For questions 3 and 4, you can if you have time. I think it's a lot easier to just like write it out and like think about it logically, because it takes too much time to go ahead and just like, like copy it all over. It will take way too much time. And this exam is way time compact. Like even this exam, it took us 2 full SI periods to go through. So that should be pretty a good indication of like how long the exam actually takes. It takes like, I don't know, like the exam's pretty lengthy. So like imagine copying all this over. Like it would take way too long. So I would not recommend doing that.
Got it. Thank
Yeah.
you.
Yeah, of course. And I'll talk about like the honor code real quick, because when I took this class, it was a pretty big concern of mine. So I'll touch on that real quick for you guys. Yeah, like some people do cheat on the exam. Obviously, you shouldn't. So they do get caught because they have like the exact same free response questions. They do run that through Moss, which basically detects plagiarism and stuff. So just be smart about it. Don't cheat. Take the exam legitimately, and the curve's always good in this exam because most people will perform like 70-ish percentage. So I know the stakes are high, but just like do the right thing. Don't cheat. That's the big takeaway, I guess, because if you do fail this exam, you get caught cheating on it, then you do fail the class and have to retake it. So at the end of the day, it just isn't worth it. So
wait, 70% raw. So like that means like probably like partial credit on like the free response. Or...
Yeah. You'll usually for free response questions, if you just write something and it makes sense, they'll give you points. Because in the rubric, let's say, what question did we do today? We did this question, right? So in this question right here, if I did error checking and I recognize that, let's say error checking is worth 3 points. If I recognized it, I'll get 2 points. If I did it correctly, I'll get 3 points. If I went ahead and I did the A to I thing, that may be a point. If I did the stuff revolving around outputting, that'll be 2 points. So there's multiple points available for each question. It's not just like either you get 9 points or 0 points. The rubric basically says student does this in their function, student does that in their function. So it's all dependent upon how much you do, but you should almost always get partial credit if you put something.
So it's not checking to see if they copy pasted our code into there, would it like compile or something?
Yeah. Like, so a bit of experience. So I took 281 last semester, which is the class after this one. And some of my code didn't compile for the free response questions, but I got perfect scores in both of them. Because the rubric, the way it looks at it is it'll basically just like look at how your code is written and say, does this make sense logically? And they'll look at it and they'll give you points based on like certain things you did. So you saw in this question how we had like multiple parts where it's like, okay, first part's error checking, second part is inputting, third part's outputting. And they'll break that apart into like multiple pieces. So this entire question is worth like 8 points. And they'll give you points like depending on what you did and didn't do.
Got it. Thank you.
Yeah, of course. And then I'll do a quick like run down the different kind of questions I can ask you guys and like tips for them. And then we'll call it a day. So strings and IO, I recommend on your cheat sheet adding in some C-style string stuff. So I think this
I think your mic's not working right now.
Thank you, God. This headset's pretty bad. Is it good now? Yeah, I think it is. Yeah. Okay, so yeah, this portion right here is really good for understanding C strings. So for question 1 in your cheat sheet, they all follow this order, by the way. Question 1 is going to be about strings. Question 2 is going to be about arrays. So it's always going to follow that format. Question 1, I recommend having your cheat sheet stuff like, okay, how do you define C strings? And what makes a valid C string? How do you traverse a C string? So add that Streamline function in there. And that'll help you, like, if you're panicking on the exam, like, oh, this is how you traverse a C string. So add that to your cheat sheet. For question 2, I recommend, also for the file stuff, yeah, add like what IS and OS do. So like the in-stream and outstream stuff. We covered that today. So just have like pound include S stream, pound include O stream. Think you're pretty good there. Question 2, all of the traversal stuff we talked about today, put that on there as well. We have references in our drive somewhere, so you can look in that as well for like how to properly traverse an array using index versus pointer. Again, it's a good practice as well. That's basically it. Problem 3, this one is the easier version of the structs. This is basically testing you on if you understand how public versus private works, and it's a struct, so it's all going to be public by default. So what we do here is, I don't have many tips for this one. It's basically just like run through examples, and I don't have many tips because like this question I thought was like the easiest one on the exam. So just, I don't have many tips for it. I'm sorry. Question 4, this one is probably the hardest one on the exam. This is polymorphism. So my tips for this is understand what a virtual class is. So if you ever see the virtual void function, understand that like, okay, I need to overwrite that in my in my derived classes. If I don't do it, I'll get errors. I have to define these 2 functions in my derived classes, or else I'll have bad issues occurring. Understand the order of constructors. So a quick review is that whenever you construct an object, you always call the base class first, and then you go like a cascading effect down. So if we were to work with this, we see we have devices, phone, and then laptop. So we have a little diagram. We have like device, phone, and laptop. So if we were to create a laptop object, we see that it inherits from device, and device the virtual class, so it inherits from nothing. So we would first call the device constructor, and then we'd call the laptop constructor. So understanding stuff like that is pretty important because they'll ask you in the exam like, oh, look at how this constructor right here, it outputs text whenever we make a laptop object. As an example, they usually do that. They'll have like, oh, the laptop constructor will see out like laptop constructor. And then it'll ask you like, oh, what's the output going to be? So have that cheat sheet out where it's like, what's the order of construction versus destruction? How do derived classes inherit from the base class? Have that on your cheat sheet. That's really important. And then this stuff, again, is basically just understanding how downcasting works with pointers and stuff. So understanding how you can create a device pointer and it points to an iPhone, how it recognizes that as being an iPhone. So stuff like that is really important to this exam. It's just having the proper material in your cheat sheet. So we made a couple of resources for that available in the drive. And that is about it for exam tips. One thing I would say, though, is that for this exam, there's multiple ways to do it. There's no right answer. But I recommend starting on the easiest question to you. So before you take the exam, look at the concepts and think to yourself, I think this is the easiest concept for me. Maybe it's strings, maybe it's structs, I don't know what it is. Find that question first and do it first. That way you know you get some points. After that, go to the medium questions and then finish off with the hard questions, because my advice for this at least is like, if this question's hard for you, don't spend like an hour on it, right? If you have 40 minutes at the end and everything else is answered and you're like, okay, I have 40 minutes to answer this question, how should I budget my time? Definitely going ahead and just dedicating all of the rest of your time to it is the right option in my opinion, because that way you know, hey, I have nothing else to do, so I can dedicate all my time and energy on this question. And that is about it for the exam. Any other questions you guys have?
I have a quick question. So do derived classes inherit the constructor of the base class?
Do derived classes inherit the constructor? Yeah. So whenever you call, here's a good, I think we have to implement ourselves. I think we have to implement the laptop constructor. Do we? Yeah, they do inherit the constructor. I think one of the questions is here is like, go ahead and implement it. But yeah, they do.
Okay, thank you.
Yeah. Where in the drive are the quick references you were mentioning for certain types of problems? Yeah, sure. So let me go ahead and explore this for you guys. So you all have access to the drive. So like in here, in week 1, Peter went ahead and made a bunch of like, he and I made a lot of this stuff. So it's basically just like, hey, that's a bad example. Week 2. Like right here, he gives like a lot of good resources. Where it's like true and false questions, and then like outputting and stuff. He did have some resources, I believe, later on in the schedule, like week 5. Yeah, like this stuff, and like the handouts right here. But yeah, that's that'll be it for today though. If you guys have more questions, happy to stick around for a couple more minutes and answer them. But that's about it for the exam review. So thank you all for coming. I appreciate it, and best of luck in the exam. If you have any last minute questions you can't find, you can email me. I'll try to respond as fast as possible. But you guys will kill it tomorrow. Good luck.
Thank you.
Thanks so much.
Yeah, of course.
Thank you.
Yeah, of course.
Wait, sorry, I just have one last clarification. So on the exam, if, when they're saying implement this function, you write out your code. If it, isn't like exactly syntactically correct, or like it doesn't compile, but, like semicolon or something, like that's not gonna be like detrimental point-wise?
They might take off like 1 point at most, but it won't be like a huge thing. Like if the question's worth like 11 points, you might get like 10 points out of 11. But like it won't be like the bulk of the exam. Like if you answer the question and your like solution makes sense, but it's like, oh, you didn't put like a const here and it doesn't compile, they won't like, I mean, they'll miss it sometimes too. They'll grade your exam and be like, oh, they didn't even see it, so they'll give you full points still. So it depends on like who's rating it, but you'll get like 95% of the points.
Okay, so it's being graded by like someone reading it and not them,
Yeah.
putting
A
it into
computer,
the-
a computer does not grade it. Yep, exactly.
Okay, wait. So let's say you use like the dot operator instead of the scope operator. Like, would that count for like a lot of points off, or?
Dot versus scope. So you mean like this versus this?
Something like that, yeah.
Yeah, they might take off like 1 point. But I mean, like that's like important though, right? Like this concept at least is like, is it a pointer or is it an object? So like that's a bad example. I think a better example would be like, oh, I didn't put like the word const here. They might take off like 1 point for that. This would be worth like 1 point guaranteed. Like they would definitely dock you down on. But like if you have like a const or you like forget a semicolon, there might be like one thing where it's like minors and tactical issues minus ½ point. So.
Got it.
Yeah.
Thank you. What about like the colon operator?
Scope resolution operator?
Yeah, the scope resolution. That's what I was thinking of earlier.
Oh yeah. They would that's a hard question. I think it depends on like the rubric for the question, but if you have to include it, obviously include it. It depends like on the exam, obviously, and like how points are allocated.
Got it. Thank you.
Yeah, of course. See, we have one question in chat. If Clement is here, I'll answer it. Are you here still? Let me see.
Yeah, I'm still here.
All right, cool. Any other questions before I answer that one about the exam and stuff?
For a C style ADT, like on a struct, you don't need to like call the function on a struct object like you do for a class, right?
No, you don't. You pass in. So what you do is you'll pass in the struct pointer if you want to modify the struct itself. So like if I have like some struct like this, like struct A, and it has like some values in it, what I'll do is I'll make like a pointer, we'll call it name, and then I'll pass in that pointer to a function, and then I'll modify that struct.
Okay,
But you don't do like a dot, because for classes you have to use the dot operator.
right. Okay. And also for classes, you have to call like member functions on the instance of the class, right?
Yep, exactly.
Okay. Thank you.
Yeah, of course. All right. So I'll answer your question real quick, Clement. So let me pull up the exam real quick, because there's an example on this exam. So right here. Okay. So your question was about virtual and override and derived classes. So the big takeaway here is that we see right here, device is going to be the base class. And we see this virtual function right here. Virtual, that means that if a derived class, so in this case, we can look at deplete power. I believe we actually implement delete power for one of these. Yeah, for phone we do. So what's happening here is that if phone has delete power implemented, what that means is that we will refer to that definition if we're calling deplete power in a phone class. If phone does not have a deplete power function declared, we're going to refer back to this. So the big difference here is that there is a definition for deplete power for this. Even though it's virtual, it's defined. That means that if our base or derived class doesn't define deplete power, that's fine. We're going to refer back to this. The big difference, though, is that for startup and get device ID, these are pure virtual. That means there's no definition included here. So we have, in our derived classes, we have to declare a function called startup and get device ID, and those have to be declared. So one of the questions in the exam is, I think it's like right here. The following code is not compile. Why is that? And that's because like for our laptop, we don't have a function. So we have get device ID, which is a virtual function. But for startup, we don't have that, right? So what happens is our compiler is going to look for a startup function in our laptop. It sees it doesn't exist, and we'll refer back to our base class. And we'll see right here that startup is not defined. It's a pure virtual function, which means that an override does not exist. Therefore, a compiler error is going to occur. Does that make sense?
Yeah, but what about override?
Like the word override?
Yeah, well, when is it used and how does it differ from virtual and derived classes?
Can you give me an example to work with?
Say void startup override in, let's say, in phone.
In phone, okay, for so for like get brand or something like that, or for like one of these functions.
Yeah.
So for like startup.
Sure.
Okay, so if we have an override there, that essentially means that if we call that, it's going to override the definition for startup. Now, I believe, I am not 100% sure on this, but for virtual, it's automatically going to have an implicit override because this is a virtual function, which means we're always going to defer to the derived class. If the derived class doesn't have an implementation for it, we're going to refer to the base class then. So I believe we could define get brand and like maybe override it in our derived class. Again, I could be wrong on that, but I haven't seen that used before, so I don't want to give you like 100% sure answer. My answer right now would be like I wouldn't worry about it too much. I think the main important thing here is like understanding how these functions get overwritten.
Oh, okay, I guess that makes sense.
Yeah, I mean, I'm happy to like look at an example if you have one, but I don't have one, unfortunately. So if you have one, I'm happy to look at it for you, but I don't have one.
Right, okay. So virtual looks at the dynamic type of the variable, right?
Yeah. So virtual looks at the derived class and sees if it defined it. If it didn't, it'll refer to the base class. If the base class didn't define it, then it will be a compiler error. If the base class indicates a delete power, if it did define it, then we'll go ahead and refer to that definition. So for virtual functions, it will always look at derived. If that's not defined, it will go to the class above it. So in this case, it will be the base class. And if the base class has no definition, it will be a error. Actually, it'll be a runtime error, I believe. No, it'll be a compiler error.
Right. So what happens if you remove virtual in laptop for get device ID?
Well, we can't do that because virtual for the base class says that every derived class has to implement get device ID. So if you wanted to get rid of the virtual in laptop, we would then have to get rid of the virtual in here. So if we said get device ID and we defined it as like return like, I don't know, like some device ID like 5, right? That's fine then, but we can't just like get rid of the virtual in a derived class if in our base class we're saying it's virtual.
So then, what about? I still don't get override though. Like
what does override do?
I know it's like they say it's something like a comment, like it's really optional, but I'm not exactly sure how it's used in application.
Yeah. So let's think about euchre, right? Remember how we technically overwrote this operator because we wanted to order our cards?
Yeah.
Okay. So there we said operator like this. We had like this, right? You can't put an override there, but it's implicit. We don't actually need the word override. Same thing for virtual. We could technically say like override startup ID, right? It's implicit though, because if this function's virtual, that's basically telling the compiler this is allowed to be overwritten. So in here, whenever we have startup is virtual. We get a virtual void startup override. But we don't need the word override because this is virtual. So it's defined as saying it's fine to override it. Same thing in euchre. When we said override for the less than operator, that's implicit because when we define the operator for the card class, we're implicitly overriding the less than operator.
Okay. So could you have like something like, let's say we don't have virtual, right? Let's say we use void startup in the base class, and for phone we would use void startup override. Would that make sense?
So you're saying like for phone we had an override right here, but no virtual?
Yeah, but without the virtual for both the base and phone.
Oh, so you're saying we got rid of like startup for this? It was like a void startup with override? I think that would work. I don't want to give you a definitive answer, but I believe that would work. Because like the reason why I don't know is because like it's just so much easier to use virtual, right? So right. I don't know the exact answer to it, but yeah, I couldn't tell you. I'm sorry. But I do know that if you have virtual, then that's implicit override. And I've never seen them ask a question where it's like, oh, if you had like this override here, then again, I'm not sure what would happen. But I would just focus on the virtual part of it because that's like what they're going to ask you.
Right. Okay.
Yeah, I'm sorry I don't have an answer for you, but it's a good question. It's just a pretty obscure question. Like I'm not really sure like what the correct answer is. My intuition is that it would work, and what you're saying logically makes sense. But again, it is C++, so there's a lot of like weird semantics that could come into play here.
Okay. Cool. I guess that helps. Yep.
Yeah,
Thank you
yeah,
so much.
yeah. Of course.
Thank you.
Yeah, of course. All
Have a
right.
great day.
Yeah. Good luck, Days. Good luck. All right. Stuck around this far. Thanks for watching the review session. Good luck in the exam. Yeah. Have fun.